Welcome to this video on number systems, focusing on binary fundamentals and conversions. In this video, we'll explore what binary is, how it works, and how to convert between binary and decimal. We will also touch on binary arithmetic. Let's dive in. So, what exactly is binary? Binary is a base 2 number system. Unlike the decimal system we use every day, which has a base of 10 and uses digits from 0 to 9, binary only uses 2 digits, 0 and 1. As shown, decimal uses digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Binary uses 0 and 1. This makes it ideal for computers, where these digits can represent off and on states respectively. Just like in the decimal system, each position in a binary number has a specific place value. Instead of powers of 10, binary uses powers of 2. From right to left, the place values are 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. As shown, 2 to the power of 3 is 8, 2 to the power of 2 is 4, 2 to the power of 1 is 2, and 2 to the power of 0 is 1. Thus, for the binary number 1, 1, 0, 1, the digits are in position 3, 2, 1, and 0 respectively. To convert a binary number to decimal, you multiply each digit by its corresponding place value and sum the results. For example, let's convert the binary number 1, 1, 0, 1 to decimal. Starting from the left, we have 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. This simplifies to 8 plus 4 plus 0 plus 1, which equals 13 in decimal. So 1, 1, 0, 1 in base 2 is equal to 13 in base 10. The general formula is the sum of each digit times 2 to the power of its position. Converting from decimal to binary involves a different approach, the division by 2 method. The method involves dividing the decimal number by 2 repeatedly and collecting the remainders. The binary number is then read from the bottom remainder to the top remainder. Let's convert 13 in base 10 to binary. First, 13 divided by 2 equals 6 with a remainder of 1. Then, 6 divided by 2 equals 3 with a remainder of 0. Then, 3 divided by 2 equals 1 with a remainder of 1. Finally, 1 divided by 2 equals 0 with a remainder of 1. Reading the remainders from bottom to top, we get 1, 1, 0, 1 in base 2. Binary addition follows a few simple rules. 0 plus 0 equals 0. 0 plus 1 equals 1. 1 plus 0 equals 1. 1 plus 1 equals 10. Note that we carry over when the sum is 2 or more, since we can only use 0 and 1. Let's go through an example. Add 1, 0, 1 and 1, 1, 0. Starting from the right, 1 plus 0 equals 1. 0 plus 1 equals 1. 1 plus 1 equals 10, so we write down 0 and carry over 1 to the next column, resulting in 1, 0, 1, 1. Binary subtraction also follows specific rules. 0 minus 0 equals 0. 1 minus 0 equals 1. 1 minus 1 equals 0. 0 minus 1 equals 1 with a borrow from the next bit. Remember, when you borrow, you're taking a value of 2 from the next position. Here's an example. 1, 1, 0 minus 1, 0, 1. Starting from the right, 0 minus 1 requires a borrow, making it 1. 0 minus 1 equals 1. Then, 1 minus 0 equals 0, and finally 1 minus 1 equals 0, resulting in a final answer of 0, 0, 1. Let's quickly summarize what we've covered. Binary is a base 2 system that uses only the digits 0 and 1. We learned how to convert between binary and decimal numbers, for example 1, 1, 0, 1 in base 2 equals 13 in base 10, and 13 in base 10 equals 1, 1, 0, 1 in base 2. Finally, we went over the basic rules for binary addition and subtraction, including carry and borrow operations. Understanding binary number systems is fundamental to understanding how computers work. Congratulations, you've completed this introduction to binary number systems. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.